Hello, everyone, and welcome to our second presentation in the data stream of the Big Data Conference 2021. And for this second talk, we're going to learn about how to achieve data quality. So in the first speech of the day, the keynote introduction, we learned about data quality, but we are now going to go even into even more detail than we did in that presentation. And Gerard Toonstra, who's engineering manager at Datafall, is going to take us through exactly how that works. And Gerard, I know you are going to tell us who you are, so I won't go into that, and I'll hand straight over to you to start the presentation. So please welcome Gerard.
Thank you, Jonas. Yes. So, hi, my name is Gerard Toonstra. I'm the engineering manager for Datafall. I'm going to be talking about proactive data quality today, and I'm going to do that from a little bit more from a technical perspective, how you would achieve that, not only from the perspective of why you would want it and all the features, but also going into a little bit more details how you could actually achieve that. So I'm going to tell you a little bit about myself first. I don't come from a computer science background. I actually have a background in nautical engineering. I spent 1 year as an officer and engineer on large container ships. In my career, I spent 7 years doing innovation at a company in Brazil called Cesar, spending some time also on the beautiful beaches over there. In 2016, I joined Coolblue, where I was actually the data warehousing team in BI, which then was quite new for me. When I was at Coolblue, I did also 2 conferences at Big Data Vilnius in 3 years and 2 years ago. Since 2021, I'm working as engineering manager at Datafall. I got a lot more into all the data observability and data quality and how you could achieve that. And I got so much into the topic that I was invited to work with them. As a hobby, I also do oil painting. This is one of the works that I did, and these are also some of the paintings that I did way back about 3 years ago. So, proactive data quality, why would it be important for you? Well, one of the questions you can ask, like, have you ever seen data break because of, for example, incorrect SQL statements, where some SQL statements didn't have the right logic and it wasn't processing the data correctly? There might have been some lack of familiarity with the data at some point, and it is very specific to where the data comes from and an understanding of how those systems would process the data and record what is important for that particular business process. There's also some issues usually occurring with bad, incomplete, or duplicate data that is upstream. So, for example, when you have ETL running for 5 train or stage, there might be some issues that would pop up and that would create some problems. There's also schema changes, of course, that the upstream data teams or the application teams would start recording data in a different way, and then you would have some impact of outage in your system. And there's probably a couple of other causes that I haven't mentioned. All of these are related to, bad data, so your data quality is suffering because of it. And what I'm going to do is to give you a couple of measures about how you can fight that and how you can actually start working on those. In order to understand this a little bit better, we need to understand that a data product goes through a couple of different phases. We talked about discovery, that was in the keynote of today, where we talked about where does the data come from, what does the data look like, who is using it. So that is a very important element of it. The second element is, of course, the ETL, where you do all the data processing and where you're starting to go through all the different manipulations of the data. And then one part that isn't really touched that well, and it's actually quite large, is monitoring on a daily basis to make sure that if there are changes in the upstream systems, things aren't going to break that easily. What I will also demonstrate at the end of the presentation is that there are some activities that you can do in all of these different phases that are going to reinforce and give you some new enablements in some of the other phases. And one of that one is specifically lineage, and I will get right to the end of that. So phases in the ETL changes, and for ETL changes, I will just first describe a couple of what they are, so we have a better understanding of why things could break because of it. So let's get into some details. For example, we have source table changes. Source table changes are that you make decisions about reading data from a different source. Sometimes a company has 2 different tables or 2 different teams that are working on the same thing. And depending on the business process that you're coding this for, one source could be a little bit better or a little bit more appropriate to read from than the other source. So when you make those changes, in this case, this is a beers table, it is important to understand what are the characteristics of the data in that other table, so that you're able to actually predict a little bit better what is going to happen downstream when you change those sources. There's other changes that we can have, which are the filter changes. And filter changes are basically, well, one of them is an implementation of the where statement, where in an ETL, you can have certain characteristics of the data that you need to split the data, filter it in a different way, and then from there, your data will look different just because your filter changes. You end up with more records, you end up with less records, and those changes can have some very big impact on the kind of data that you're delivering. The other changes that you would sometimes see are grain changes, and a grain is basically if you're going to keep things in your data warehouse or your table at, for example, order level or order line level, and that is a lot of the time related to the group by statements that you're going to do at the end of your statement, so that you are rolling up the grain, and then sometimes you just decide to propagate the grain as it is from the source system. And here that is also, of course, important because you need to be able to combine and join on this data later on in your data warehouse. And of course, also very relevant is table join changes. Here, sometimes from my experience, you see that you might get some order numbers into the data warehouse, but you might not get all the order lines related to it. And then in some changes or in some business processes, they want to know the number of orders. They might not be so much interested in order lines. So then there might be a need to introduce some left joins that will, of course, have an immediate effect on the number of lines that you're producing in those tables. So those are 5 examples of ETL changes that can occur, that can have some disastrous impact on your data warehouse. And of course, we have the calculation change as well, which is where you're introducing some new calculation rules. Here I made a very simple example about a hacky way to calculate the VAT rules, for example. But if you think about a more elaborated example, then those calculation changes can have an immediate effect or will have an immediate effect on all the metrics that are going downstream, especially when you're looking at the reporting phase in BI. So one of the questions that you need to ask yourself, you're working on an ETL change as a data warehousing team, a data engineer. How are you going to make sure that when you make those changes, that it is doing the thing as it's expected, and if it is needed to be used at the very end? So typically what we would do nowadays is these code reviews. And here you see that there is a suggested change, and then someone says, looks good to me, and there's even a rocket symbol to ship it. And there are 2 changes in this one. One of them is there is an extra column, and the other one is a filter that was actually removed. So there are, of course, now a lot of possibilities to do automated checks on it. Here you can actually run a DBT on it so that you know that it compiles and that it did run. We have another check in here that is from the Dataflow product, which does something else. I will show you that how that works soon. But the point here is that even if you have the automated checks and you have your code review done, it doesn't necessarily mean that the changes that you have created are behaving as they should. So here we see, for example, that the changes were introduced in the acceptance environment, and on the acceptance environment, all of the blocks are green. So we must be all good. We must be ready for deploying the code, right? Well, what happens is that that is not necessarily the case. One of the reasons is the data that you have is outside of your control, the boundary of control for the data warehouse. You're basically taking all the data in through ETL. And what you would normally think of being suitable for use when you run CI for applications, when you think about functions mostly, isn't really the case when you think about data warehouses, because the primary concern of data warehouse is about the data. So you care more about the data state than you care about the functions. However, when you run the CI, you do not necessarily have a very good process for making evaluations and assessments if the data is indeed correct in that case. So what we end up doing after these stages is usually data validation by the data engineers or the stakeholders. And in order to do that properly, there is a lot of context that is necessary on how the data is going to be used. So the context that we need here is related to the business processes. And there can be many cases where even if you process data in the right way, how you think it should be processed, isn't necessarily appropriate on how business analysts or report analysts want the data to be presented. So you need to have a good understanding of those business processes that are going to use this data. It takes a lot of time to craft those validation queries. The first thing that you would probably do is just run a couple of simple record counts, and then you're going to look if some of the columns look okay. And after that, you start to think about more complex scenarios to make sure that those things are looking okay, right? The question is also, are those validation queries correct? If the table that you're producing is a little bit complex, then it is possible that the validation query itself is missing very specific cases in its own where statements or in its own joins. And that could mean that when you do the validation that you're thinking that things are okay, when in fact something very important has been missed. So the other thing that is also complicated with data validation, and that is especially when I worked with Coolblue, we had some business analysts that needed some data for doing some kind of analysis or producing a report, and their availability was not always 100%. So we would produce some kind of data, we would have it running on acceptance, and then on that particular day, they didn't have any time on that day to make sure to do the validation themselves. So you have even when you do the production and you do all the development by the data engineering team, you run into a situation that it can take a lot of time for that pull request or for that change to be merged into production so that it is actually done and the issue can be closed. So one of the questions that we need to ask ourselves, is there something that can automate in this phase of the data development process? Because it appears that we're doing already a CI and the code review and then the data validation. So can we make it a little bit simpler? Well, one of the things that can be interesting to do is to look at data profiling that you would typically do for some new tables. This is an example of the Data Vault product that we have. A table profile is basically just looking at the total number of records. We're looking at maybe some metadata coming from the comments. And we're also going to look at all the distributions of the columns at the bottom, the amount of nulls in all those columns, and so on. When you have a table profile, that gives you basically some descriptive statistics about the table itself, and you can get some insight per column about what is in that data. So when you produce a new table, this can be useful if you have an idea about what should be in the table, more or less, that you're going to be able to evaluate if the processing from the ETL has been correctly processed or not. So this can be a fully automated process. So if you have the table profile and you have a production table and you have another table that you are actually working on to where you made a change, then the suggestion that we have is that you're looking to data diffing. So the data diffing is actually the real CI for data, as I explained, because we're not focusing on the function, on the SQL statement itself, and if that correctly executes, because that is very easy to check, but we want to make sure that the data that we have that is upstream, that you do not fully control, is actually being processed correctly. And that means that when you look at all the output of what it produces, and you have a known good, which is the production version, you can use the data diff version to look at the changes that would occur if you would go with the changes between the changed version and the production version. And here you can actually use the descriptive statistics, because you can look at the min and the max differences. You can also look at a sample of the changes that you would have between the two. And when you run a full data diff on it, the way how we implemented this is that it becomes like a comment on the pull request. So here somebody makes a pull request. Datadiff is going to run on the data vault server, and then it will post this summary on the pull request itself. And if you want to go into further details, you can go into the rest of the system. So what this looks at is basically all the primary keys. It tries to match them together because you need to compare row by row. It's going to look at all the nulls, the row counts, the data distributions per columns, and just look at all the differences and give you like a useful summary. So that is one way that you can do that. The complications, as I said, is that Datadiff requires a primary key, and many data warehouses, BigQuery and Snowflake, do not have an explicit way of defining that. So that is one of the challenges. And one of the things that is actually very helpful is if you look also at different ETL tools to use. One of them is DBT that will actually give you a very important and interesting manifest about how the data was built. It contains lots of metadata about the ETL process itself that you can also use for some different purposes. So that is one way to actually extract it and understand which tables had changes in them, and then from there run the Datadiff in an automated fashion. The complication of Datadiff has a little bit of other components, because if we looked at one single table, and of course that is very easy, but the actual differences that would occur also need to be looked at as the data moves downstream. So for example, if you have a customer stats table where we introduce the change, then that table would change, but as it gets joined with customer and address, it is very likely that the DIM customer itself table is going to change, and that it would have some downstream effects on the churn report in BI, for example, and probably many other reports that need to have some interaction with the DIM customer table. So it is really important for those dimensions to be correct, because if we have too many rows or not enough rows, it can have disastrous effects on all the downstream processes and reports. So the thing that I was suggesting, using a Datadiff that is automated will assist validation. It will not negate it because there's still a need to do that, but it increases the efficiency for it quite a lot. It helps to avoid unintended data changes. So it is possible that you created a new query or a change in the query, and you made some assumptions about what the nature of the data was. Sometimes we have 80% of all of the columns failed usefully, and then 20% of nulls because there was at some point a not very well known data outage or a change on the source system. So the validation can then focus on more complex impact analysis. We don't have to run all the record count analysis anymore. We know more or less what is in the produced table already, and then from there we make an assessment if we should look into it in more detail. And from there we can do a better complex analysis. What we will also see is that with lineage, this process becomes even more powerful. That is very much related to the understanding of how all these tables are being produced downstream. But there is also another thing but that would allow us to do that already using the DBT metadata, for example. So the other phase that I'm also going to talk about, because this talk is short, is data monitoring. And monitoring is basically thinking about this problem. If you have a code that is completely correct, will you produce the correct results in your end result each and every time if you don't make any changes to the pipeline? Well, if you think about it, then basically you can basically know that there are many changes that happen in all around the company. So applications are changing the schemas, applications are also changing the way how to record the data. So this won't be true. At some point there will be some outage because of some failure in the system upstream. And if you are working on different issues in different areas of the data warehouse, you won't see it. And that is where the reporting comes in. The reporting team is telling that one of the reports look really weird. And that's probably because something that broke in a different system that you consume data from. So a lot of those things are related to, they are not your fault. They are a different team that did something that you weren't aware of, and that will have some consequences in the systems downstream. So what are those external causes? Well, we have a couple of them listed here. So let's go into some of those in more detail. Here we have the application that is upstream, which is can have some data in an RDBMS. we ingested that using Fivetran, Stitch, or Airflow, or other processes. They led it to your data warehouse. But then what happened is that they saw that the customer ref isn't appropriate. Someone in the business wanted to change it, so they introduced a new customer ref new that we are now going to use to record those customer references. If you don't account for that in your data warehouse, then this is an example of how a schema change would break your downstream processes. Because from here, you would have only the old customers, but the new customers would get recorded with a new reference, and it would probably not end up in your customer dimension. So that can have disastrous consequences to a very large number of reports. There are conceptual changes, and this is one of those examples. When I was working at Coolblue, we had something called an order source. And that's basically thinking about what is the source of an order. Is it made from internet sales or is it made from store sales? There are sometimes people that want to further distinguish what the source is and how this order gets processed. And then they make decisions about that they want to further divide that into internet sales, store sales, but also an internet sales of a store pickup or a store sales with a delivery that was done using one of the delivery vans. So then from one day to the other day, you have 2 additional new order sources that will get used. The number of internet sales that you're reporting is going to drop. The number of store sales is probably going to drop. And you will get some 2 new order sources that you're not reporting at all. So those also have to be worked into the new data warehouse process in order to do that properly. There's of course always the possibility for duplicate data that is related to the ETL. It can happen that something was restarted because it failed, producing different duplicate data, or things are asynchronous and there's no guarantees about single delivery, but maybe only multiple delivery. So those are some other things that can happen from the source. And this would have the impact that, for example, for this customer, you would get double the orders or double the sales being counted. And there's a possibility for incorrect data upstream, where, for example, you record the stock value, what's the value of that product as it was stored in the data warehouse. One of those examples is that there wasn't any validation on the stock value, and that could lead to some products being registered where the comma was misplaced. So then you would get a very high value for one of those orders. And this has the consequence that when you start calculating the margin, then your stock value is way too high. And that means that the margin that you're making on that is negative. So you sold it expecting $300, $400 of margin, but you actually in the data warehouse for that single order line, you might see one very negative margin. So that has a direct influence on probably a number of reports where people care about Apple products, for example, and the sales of that or the margin that they made. And it can also have, well, it will have direct influence on other reports when they're looking at phone products, for example. And this one can be quite difficult to track because it isn't necessarily marginally or that high or different from all the others. When you take an average of the margin, it doesn't necessarily show up. But it will show up if you look at the min-max, for example. So what a lot of data teams are doing in this regard, and that is also something that was done a lot on Airflow, for example, they would run some of those alert queries, as you could call them. Here we're just defining 2 different metrics that we know very well, where we say we know what the average margin on a particular day would be, more or less, considering all the different products that you would sell, and then they would fall within a particular margin of one another, or maybe they have some different thresholds that are being set. That would actually allow us to track them and alert them. So here what you see in this implementation is one, we have a detection mechanism for it, and the detection mechanism is the query that we are running. Second, we have an alerting mechanism on it, so we will actually define that the number should be less than 5, otherwise it would create a failure. And when this query fails, it would also send out a notification. So there's one of those things that I'm going to go into this alert query. What is the return on an investment that you would get from that? Well, first of all, you need to schedule its query. You also need to notify on it. So it isn't necessarily a good thing to notify on everything that you would see going wrong in a data warehouse because of fatigue. It will only monitor those things that you have actually implemented. So if you're missing a query that is really important, then you won't get notified about that. So you need to put a lot of effort into covering the entire area that you care about. And I already mentioned the false positives and the fatigue. Is the threshold okay? If you have a lot of seasonality in the data, then it means that for certain days you might get a lot of those false positives, but in other cases you might not get them at all. So doing this properly is probably requiring quite a lot of data science experience in order to understand what the real threshold should be and what should be the approach towards detecting this. And the other thing is that we looked at, I was actually involved in a project with Coolblue where we started looking into this kind of monitoring system. And when you run a single query that would append one record, and you do that a lot of times, then, for example, on BigQuery, you would end up hitting the quota for the number of queries that you can run for that table. So it isn't a very useful way to run these as queries. There needs to be some kind of different mechanism for it. But the thing is, for this particular approach, I think it works very well for complex metrics where you're really thinking about indeed the average margin, or you're thinking about the average margin per order, for example, because they are very easy to express in SQL. So there are a couple of systems that are now in use or available for observability. And I'll go into detail of one of them that is open source. But it is really important for the design of those systems that you're separating the collection, the detection, and alerting in different stages. And the reason why you want to do that is because of testability. When you're working on these items and you have one query that also fires a notification, then it is very difficult to, if a person says that they want to go on holiday, to ignore those people. So you're going to send out a lot of alerts, and then at some point all those alerts are going to be ignored because you don't have a good way of managing them. So the collection phase is where you're looking at what are the metrics and where you get them from. That can be queries, or they can also be taken from different sources. There is a mechanism more like a rule engine that will then determine if those metrics that you're collecting, if there actually should be a reason for some anomaly that you're detecting. And in the third phase, you're actually going to think about who should I be alerting when this thing happens. And that's why you get rules, for example, that if there is an alert that is just producing too many notifications, that you might be able to suppress that in an alerting submodule where you are going to be able to keep all those alerts fresh and relevant all the time. So one of the things that you could look at, and that is also quite interesting, is this open source project Verti that is a well-documented approach to the problem. LinkedIn and Uber have both worked on this open source project, and it gives you some kind of handholds about what would be a suitable architecture to attack this. So the architecture that they have is reasonably documented. You can see what they were thinking about and how much effort it took them to configure and to tweak. And there's a sophisticated rule engine in there. And the rule engine needs to be sophisticated because when you have all those different metrics coming in, like a stream of the record count and maybe some more advanced metrics, then there might be cases where you have some conditions between those different metrics, conditionalities. So you have a multi-metric detection. So for example, if the number of records is above 10,000 for a particular day, and then if the average margin is below 20, then the combination of those should trigger the alert and not just the number of records by itself. And that's how you can actually also have a second mechanism for tweaking all those different notifications. So the other thing that is really cool and interesting is that you can also use that for detection and alerting by dimension. Because sometimes when you have a company that starts in a new country, for example, then you want to be able to just detect things when you have a particular country where you're already active in for a long time. So you know exactly how that country behaves in terms of that metric, but maybe you want to ignore it for the different country that you're just becoming active in. So this separation of the detection and the alerts by dimension will help you to do that. We want to ignore it, but also second, it will allow you to pinpoint and very specifically set different thresholds for depending on the dimension that you have in that column. So this is a picture that I got from the Verti website. And here we see about, well, first the complexity of that they have built, right? But also the complexity that goes into doing this properly. There's a lot of different components. As I said, there's you can basically split this picture into 3 different phases. You have the collection phase, how the data goes in. Then you have the detection phase that determines when some alert triggers. And you have the alerting phase where you can actually fine tune who is the recipient of all those alerts and if there is a need for actually triggering more alerts as we go along. One thing that is not really set out well here is also how lineage that I was talking about is going to be able to contribute here. And we're going to go into that a little bit later. So the way how these systems use, and this is not always apparent to people who are looking at this, is that you're going to be working with a lot of time series and probably only time series. So you're producing like the min and the max for a column. You might be producing the average for it, the variance, kurtosis, skewedness, and a number of categories that you have in those columns. And they can all be represented by just a single data point on a particular interval that is relevant for that particular table when it gets updated. So you would end up collecting a lot of those time series into a particular storage system of choice. In the case of Verti, they have chosen Apache Pinot, which is probably quite well difficult to set up and get going. But the benefit of that is that you have a system that is basically infinite in terms of linear scalability, right? They are handling LinkedIn, for example, is using Apache Pinot for doing all those queries, what is relevant for your timeline. So what we see here is on this screen is like something that already has one of those dimensions related. Here we see, for example, that on a particular Halloween or some particular holiday, there can be a dip or some unexpected dip in that particular metric. And that's how you can actually further use all of that information to fine-tune your alerts a little bit further. So time series is going to be the core element that you're going to be using when you do this kind of monitoring on a daily basis. So what is necessary for a data observability? There's a necessity for ongoing data monitoring, because even if our ETL is 100% correct and we don't change it, there will be times when it is going to break due to upstream data problems. In order to do that, we have to define the phase of, or make a design that allows us to collect and detect an alert in 3 different phases. So we shouldn't be combining that because it gives us problem later. So we can focus on collection first, then we can focus on detection, and then we also need to have some way of fine-tuning the alerting so that people do not get too many alerts sent to them. Verti is a great example to understand what that design would look like. You might even be able to install and use it. And what you then would say is that we talked about CI for data in the Datadog example. What this would give you is more like a Datadog and Sentry for data, because Datadog in the same way is also a time series, except that the time series that you would have there is probably doesn't not necessarily always have the same window that you would care about for data warehouse intervals, because it is typically a much smaller time window of updates. So that's why it is not necessarily useful to do this kind of data observability in Datadog itself. So the last phase I was going to talk about is data discovery. We had an excellent presentation this morning in the keynote from Mike Grover. It is also a very relevant stage. So I'm going to probably be talking about a lot of the same things and covering it. Why is the data catalog important? Because we are going to look at the stage before we start building. And what does that mean? Well, we have new starters and they need to find a way around data. If you are a data analyst or a data scientist, You don't know anything about the tables that are available and where you can find them. So when you have a system that tells you where they can be found and what is in those tables, that is already a good way of getting started as a person, as a new employee. So the other thing is that is also very apparent when I was working at Coolblue is that if you don't have a catalog, people are going to acquire this knowledge as they go along in their job, and it means you have a lot of tribal knowledge, and tribal knowledge is essentially impacting you, because when those employees leave, you will see that the knowledge is also disappearing, and the knowledge about how the table was built and what it contains, it will disappear, and you will duplicate effort, because you will have to reproduce those tables, because you need to know where the data comes from and how it was produced. So the reliability and the state of the data. So for example, the examples that Mark made this morning was about when was a data table updated, and are people actually using it? That would be in a data catalog as well. You want to be able to contact the owners and the users of the data. And you need to take into account that some warehouses have thousands of tables. We have some customers that are working with 10K plus tables, for example, and keeping track of all of them is just impossible when you do that on a manual basis. Even when you have tribes of people using the data, it becomes very difficult to find those people and to understand how you can actually use them properly, because you need to know what's in there. So basically what you could say about the data catalog, it becomes like a data warehouse browser with a search function that allows you very easily to navigate about what the data is, where it is located, and who you can contact in order to know more. All of that started quite some time ago, I think, with a blog post with Airbnb. They had this amazing data portal product, which I think from there was actually Amazon that was built from this example. And we now have a couple of different data catalogs available. There are more in the market, like some examples were given about curated catalogs like Alassian. Here are the ones that are built in different ways. For example, we have the data catalog that comes from Amazon, which has a different ingestion mechanism for it. But you also have a data catalog already in dbt, which is an ETL tool. So then it is built from the kind of processes that you're running in your ETL process. The one at the bottom is a very small example of the data catalog that we have. We are also looking at the data distributions, basically the table profiles that you would have in there. So the common features of a data catalog that are important in order for this discovery is the texture, so the table and the column and the owner. You want to be able to find all the data with some search key terms to understand what the freshness is for each table, the descriptions of the tables and the columns, and they can be different ones. You can have a schema description for the table and the column. You can also have a description as given in the dbt ETL system, and also user-based descriptions of tables and columns. So you need to distinguish between all of those. There can be something about frequent usage of the table and frequent joins. The table owner is usually given. We have the classification and the labeling of it, that is already mentioned. And then we might have a table profile in there that gives us some information, especially useful for data analysts and data scientists, about what the distributions are and the number of nulls that you can expect. When you go through all of that, we can see that one feature is missing, and that feature is data lineage. This is a view from our system where we have column level lineage on all the data tables in the data warehouse. What it does is it shows you the relationships between tables, but it also shows the relationships between the columns. So here we have, for example, the upstream and the downstream links in the catalog UI. We are going to be able to show some of the other information about the column types and how they relate to one another, the manipulations. The way how this becomes relevant, and that's what I was hinting at before, is that once you have data lineage, you're going to be able to give some more boost to your data divs, because you understand how data is flowing downstream, which you can also get from the dbt output. But here you get some more detailed output about what is relevant for this particular change, and then give some extra boost to that process. And also for the data alerts, if you know that one table is out and you have some anomaly in there, and that another table is also producing alerts, you can consolidate those together, and that will allow you to just send out one alert instead of 20 alerts, because there are 20 tables downstream. That is going to create a lot of alert fatigue. And also, there's the data categorization. If you mark one as PII, that column, when it gets propagated, it will be propagated with that label on it. So there's a lot of things that you can improve from the data lineage. Here is one thing that you can get it from DBT. So that is when you produce all the ETL tables. And this is an example of how we would do it. And that's by looking at all the queries that are being launched into the data warehouse. We process all of this query history, and that gives us the ability to produce that very detailed lineage graph, and also understand how, for example, BI tooling use it, because a BI tool wouldn't be stored in DBT, for example. So the point is that proactive data quality is about understanding this process. You have the ETL phase, you have a monitoring phase when data is in production, and you have the discovery phase. And when you get them to cooperate a little bit more and feed into each process, over time your data quality posture is going to be a lot more, it's going to be improving a lot. So we're going to use the data disk to avoid breakage. We're going to be using data catalogs with lineage support for the discovery. And in the monitoring phase, we're going to look at the collection detection to do then the alerting on that basis of the anomaly triggers. That was my presentation so far. Thank you so much. Let's start with the questions that are in the Q&A, if there are any questions.
Yes, thank you very much, Gerard. Great presentation, very detailed and thorough. I really enjoyed it. Now, audience, if you have any questions, please ask them now. We haven't had any posted yet, so this is your one and only chance to ask Gerard a question before we finish up. Now, Gerard, while we get questions from the audience, I noticed a couple of things that you mentioned there. So one thing is you said that these. Actually, we have a question now from Azad. Could you please share the tool name for the data lineage visualization?
Cool. Yeah, that comes from our own product, Data Vault. So we have a web user interface that has the catalog in it, and it also has the data lineage in there. So that will basically give you it on the web view. That's what we have used to produce that screenshot. But there are probably some other tools that you can use on open source, but I don't know them by heart. I haven't looked into those. Yeah.
So another question. Good. Thank you, everyone. Now we're getting there. So Tadas asks. So he says, impressive. Data diffs looks like a game changer. Any chances for integrations of Microsoft products in the future?
Possibly, yeah. So we are working with Google Cloud, BigQuery, and Snowflake most of the time. We're doing that also with DBT. But if you're working with DBT products, it is easier. If you're working with Microsoft products, it is important to understand that we have a little bit of an understanding of what kind of tables it is operating on. Then it becomes easy. But it is something that you can ask us. My email is over there. You can forward the question to me, and I'll have some people look into it.
That's great. Now we're getting there. Lots of questions. Cool presentation. So that's good feedback. Ramunas asks, how do you select a data catalog tool? What features do you look for?
Well, I think if you look at the keynote today, I think they gave some really very important features to look into. So I would say you want to have some understanding. Well, definitely metadata has to be in there. You could consider table profiling if a lot of analysts are using it and data scientists, but also the ability to understand how many people are using it. That can be very important. I would indeed also go for doing an automated build of it. So you have a lot of metadata lying around in DBT comments and descriptions. and the schema and so on. If you the more automation there is in it, the higher it's used, because you're avoiding all the necessity for people to produce documentation. I think that is one of the essential features. And of course, lineage, if it does that, then that is absolutely amazing, because it will give you a lot of different capabilities to do things from there. So if you have a catalog that will also allow you to extract this information of lineage, then that is very useful.
Okay, we have 2 more questions, which we might over, and you just answer them very succinctly, Gerard. So Anna says, I'm a rookie to this. Is there, there's a lot of information to take in. Is there somewhere where I can read up more about all this?
Yeah, so I gave a couple of hints about Verti, for example. If you want to, you can basically look at all those different sections separately. So that would be my tip to do that. Read into Verti, read into DataDiff and how you would apply that, and also read into some other things for the data observability, like Amundsen. Give it a start, see how that works for you, and then from there, from the practice, you actually learn a lot more.
Yeah, okay. I'm sorry, Leslie, the last question, we probably have to move on because we need to get to the next talks in 4 minutes. But please reach out to Gerard directly. He's got his email address there. So if you want any information, I'm putting words in your mouth here, Gerard. He's more than happy to take questions on email as well. Gerard, thank you so much on behalf of the audience for taking the time to present to us today. Really informative and helpful. And to everyone out there, I hope you enjoyed the talk, and we'll see you on the other side in less than 4 minutes. So thank you.
Thank you very much, everyone. Bye-bye.